minus I. For minus I, what we have to follow? Which trend we have to follow? For minus I application, DNP. DNP rule. DNP rule. First one is a distance. First one is a distance. Of course, first factor is a distance for inductive effect. Either plus I or minus I, it is completely distance dependent because of the sigma polarity, which is directly connected to more En difference element. So it is we are getting more polarity. Here only we are getting more polarity. That is more what is that generation of more electronegative elements. So that's why here distance is the first factor. Generation of more polarity, which is directly connected to the effective atom, is the factor here. That's why distance is first. Next one is what here? Number of substrates, number of effective factors, whatever the order. The last one is what here? Priority. Last one is what, beta? Priority. Distance, number, priority. Let's see the application of this rule. So, what is that? Carbanion is stabilized by minus I effect. Okay, that factor. Let's see now. Carbanion is stabilized by minus I effect. So now here carbanion is there. This is having carbanion, right? Here now here one Cl is there. Next one here one nitro is there. Here one nitro is there. Of course, according to minus I effect, which is stronger minus I? NO2 is stronger minus I than Cl. Am I right? NO2 is stronger minus I than Cl. But we should not consider priority first. We should not consider priority first. We should consider DNP rule. First factor is what here? Distance. So here this is the first carbon is connected with minus I element. Here second carbon is connected with minus I element. So which is having stronger minus I? Which is having stronger minus I? First one is having stronger minus I because here polarity, generation of polarity is exactly based on which one? Distance, which is near to some particular target atom, that is polarized much more. That will be polarized much more. So your generation of polarity is depending upon exactly what distance. That's why here stability of carbanion, first one is more than second one. Even though NO2 is stronger minus I effect than Cl. So like this we have to find, use this DNP rule, distance, number, priority. Now tell me, first one, so now here carbanion is there, here one chloro, next one here carbanion is there, right? And here one fluoro, next one is what? Carbanion is there, carbanion. It is having what here? Nr3 plus, next one, here carbanion is there, carbanion, next one fluoro, one chloro. Now find out the order of the stability. Order of the stability. First one is the distance is the factor. Distance is the factor. So first one no. Here first one no. This is which carbon it is? Second carbon. This is which carbon it is? Third carbon. This one only first carbon. And this is having first as well as second. First as well as second. Now which is stabilized? Which is stabilized? First distance parameter is over. Distance is what having what? Fluoro is same type of priority. Then here in this molecule extra Cl atom is present. That's why it is more stabilized. It is more stabilized. Second factor here, first priority. Here 1, 2 with same prior atom in the first carbon. Here first carbon fluoro atom is there. So 1 and 2 is over. Next one, here second carbon, here third carbon. This is of course stronger. This is of course stronger minus I effect. But distance is the factor. So now here, what is the order? This one is third one. This one will be fourth one. So this will be the order. Overall order of the stability of carbanion. Overall order of the stability of carbanion. Okay. One more example. Cl minus, C minus is there. Now there would be 3 carbons. Here one chloro is there. Next one here C minus. So now here we have what? Only one chloro. Next one is what here? C minus. So here we have what? NO2. Now find out the answer. Stability. Find out the answer, beta. Stability. First one distance. Distance is the factor. First one. So carbon directly connected. carbon carbonium, second carbon is connected. So carbon carbonium, first carbon is connected. This one leave it. 1 and 1. First distance is a factor. Distance is okay. Second factor is what? Number. Numbers are also 1 and 1. 1 and 1. Number is also same. Then priority. Then priority. So which is stronger? Minus I. NO2 is having stronger minus I. That's why this will be 2. 1 and 2. And the last one is 3. The last one is 3. Second one. One more set here. C minus. C minus. So this one is what? NO. C minus. Fluoro and fluoro. Right? Third one is second carbon NO. Second carbon NO. Fourth carbon. So here fluoro. Here NO2. Now find out what is the order of this stability. What is the order of this stability? First one is what? First carbon is having branch. First carbon is having branch. Second one is having first one, second one. Now see, use DNP rule. Use DNP rule. First carbon, first carbon, first carbon. Okay. First one is having only one number minus I. Second, this one is having what? Two number minus I. This is having only one minus I. So distance is over. Distance is same. Second one is what here? Number of minus I components. So this is having more number of minus I at the first carbon. That's why it is having stronger minus I effect, which means more stability. Second one. Here, next one, first carbon 1, first carbon 1, distance is same. Then on the same distance, number we have to choose. Number which one? Here only one substrate is there, nitro. Here only one substrate is there, one nitro. Second one, this is also same. Then go through with priority. This one will be the last now. NO2F, NO2F, NO2F. Which is stronger? NO2 is a stronger one. That's why it is second order in the stability. This one will be the third one, and this one will be the least one, last. Okay, this is the stability order. Like this for DNP for which one? Minus I effect, DNP rule. Distance number priority plus I effect, DBN rule. Plus I is what? DBN. Distance branching of methyl or ethyl, whatever. Next one is what? Number of that methyl or ethyl branching elements. Number of prior. Next one here, branch here, priority. These two are different. So like this, by using this plus I and minus I effect, by using this plus I and minus I effect, you will be able to find what here? Stability of intermediates, carbocations, carbanions. Carbocations, carbanions. For carbocations, DBN. For carbanions, DNP rule. DNP rule. Next application is what here? Acidic nature. Next application is what, beta? Acidic nature. Acidic nature. Acidic nature only because organic substances are weaker acids. Only mineral acids are stronger acids. The degree of dissociation for the organic acids are lesser than 100%. That's why these are having only acidic nature. But among two or more than two molecules, how to find the organic nature trend? Which is more acidic nature, which is less acidic nature? So one of the important application is what here? Plus I minus I. Plus I minus I. What is acidic nature actually? What is acidic nature? Organic substance is there. Now it is connected with one hydrogen. For example, maybe hydroxy, carbon CH bond or COH bond or NH bond, whatever the bond. Acid is nothing but what? Liberation of H plus ion. Liberation of H plus ion. The ion, the molecule which gives H plus ion is said to be what here? Acid. So after liberating H plus, what is the expected charge? Charge is what here? Negative. Not only carbon, either oxygen or nitrogen or COO or OH, whatever the bond, that is what here. This is called what? Negative charge is called what here? Conjugate base. Conjugate base. So what we have to consider here? The conjugate base, what factor? Conjugate base is actually intermediate, charged particle, intermediate. So now according to plus I minus I, how to find this acidic nature? Actually, acidic nature is directly proportional to stability of conjugate base. Stability of conjugate base. If conjugate base is stabilized, now it can liberate H plus ion easily. So it is stabilized. No problem. It is stabilized. That's why the conjugate which is giving the conjugate base stability, then that can act as what? Stronger acid. So this will be the stronger acid. So that's why acidic nature is directly proportional to conjugate base. Conjugate base is nothing but here most of the condition. What is the intermediate? Carbanion, not carbanion, negative charged particle. Negative charged particle, right? And the same application here. Stability of negative charged particle. Stability of negative charged particle is directly proportional to which factor? This is the electron density. This is the electron density. We have to minimize the electron density, which means any electron withdrawing group is present. Now it will be stabilized. That's why here this stability is directly proportional to minus I. The stability of the conjugate base is directly proportional to minus I. Now that whatever the conjugate base, maybe CH, maybe OH, maybe NH, whatever the bond, stability of conjugate base, which is stabilized by minus I and destabilized by plus I, then you can find out here acidic nature. And one more thing here, acidic nature, if acidic nature increases, now Ka value is also increased, which means here acid dissociation constant. If Ka increases, then pKa value will be decreased, right? Now here stability is directly proportional to which one? Acidic nature, which means here stability of negative charge. So by using this formula, whatever the sequence, you will be able to find whether it is Ka value or pKa value or acidic nature. Ka value, pKa or acidic trend, whatever. So overall factors depending upon which one? Stability of conjugate base. Stability of conjugate base. So one example here, alcohol. If we take here alcohol. So now here CCOH is there. Next one is what? COH is there. Next one is what? CCOH is there. Now, what is the acidic nature order? What is the acidic nature order? What is the acidic nature order? Acidic nature is nothing but what here? Removal of proton from oxygen. Here you may generate the more polarity of the bond. So removal of hydrogen H plus. Removal of hydrogen H plus. Remove here also H plus ion. What is the expected charge of oxygen? Minus. So these three negative charges are called what? Conjugate base. Now choose the stability order. Conjugate base. So it is what here? Plus I. It is what here? Plus I. It is what here? Plus I. So which is having more plus I effect? More number of branches. Next one this one. Last one this one. So here stability is what? Inversely proportional to plus I effect. That's why which is more acidic nature, which means which is more stable conjugate base. This will be the conjugate base. Conjugate base is directly proportional to acidic nature. Second one is that this will be the second one, and this will be the third one. Which means here primary alcohol is more acidic than secondary alcohol. Secondary will be more than tertiary alcohol. So by using this I effect, we can find what? Acidic nature. We can find what here? Acidic nature. Same application we may use for which one? Carboxylic acid. Carboxylic acid. Ethanoic acid is there. Ethanoic acid. Next one is what here? Two carbon like this. Next one, or else okay, propanoic acid, take it here, propanoic acid. And the last one is what here? Last one is like this, right? 2-methyl propanoic acid. 2-methyl propanoic acid. Now what is the conjugate base? O minus is the conjugate base. O minus will be the conjugate base. O minus will be the conjugate base. Now find out the order here. So first one is what here? Only one methyl plus I. Next one, this one methyl and extra methyl is present. So 2 plus I. Of course it is stronger plus I than this one. But anyway, plus and plus both are there. Next one here, 3 plus I groups are present. So here plus I is maximum. If plus I is maximum, stability of conjugate base will be decreased. So which is having more acidic nature? Which is having more acidic nature? This one is 1 and this one is 2 and this one is having the least acidic in nature. This one will be the least one. So this is the order of acidic nature. So we may see few more examples. Okay, so this is the order of acidic nature of alcohol and carboxylic acid. Alcohol and carboxylic acid. Check it, beta. Right, beta. Let's see few more examples of acidic nature trend. O minus C COOH. Next one, N minus C COOH. Next one, O minus is already over, right? C minus COOH. Next one, SO3 minus CCOOH. So which is having more acidic in nature, or what is the trend? What is the trend? Actually, what is the effect of this one? Let's say, see here, distance is the same factor. Distance is the same factor here. Next one is what here? Effect. So what is the effect? This one, plus I. This is also what? Plus I, because more electron density. This is also plus I because of negative charge, more electron density. And what is the role of SO3? What is the role of SO3? Guess. What is the role of SO3? Plus I or minus I? Of course, it is SO3 minus. Electron dense. Electron dense. It is denser. It is denser. But what is the effect here? What is the effect? Plus I or minus I? Minus I. This is having minus I. In the last class it was discussed already. Because what is the reason here? Yes, double bond O. Yes, double bond O. O minus. So any two oxygens are delocalized. I mean, the two are participating in the delocalization. So maybe if it is like this, that is okay. But this is what En difference is generated. So here sulfur is getting partial positive charge. Sulfur will be getting what here? Partial positive charge. Partial positive charge is nothing but electronegative. Electronegative is favors for which one? Is favor for which one? Minus I effect. Now out of all, acidic nature is directly proportional to minus I. Acidic nature is directly proportional to minus I. Am I right? Acidic nature is directly proportional to minus I. Second one, least plus I. Least plus I. So which is least plus I here? Which is least plus I? Least plus I, which one here? Least plus I, which one? This is stronger plus I. This is what here? This is what here? Next one here what? Yesterday it was over already, the trend of plus I effect. C greater than N greater than O. Right? C is what here? Less electronegative element. Less electronegative element. More plus I effect. So this is more plus I. More plus I is nothing but least basic, least acidic in nature. Next one, this is actually what? First one, right? This one is the what? First one. Sorry, this is the second one. Second one, third one. First one is already over. This is the minus I. Minus I. Next one, second one is what? Least plus I. Somewhat more. Most plus I. The last one. So this is the order of the acidic nature. Check it, beta. This is the order of the acidic nature. And here, after this one more important point here. One more important trick here. So how to find acidic nature? Here, one thing will come. What is it? C double bond O minus. C double bond O minus, which means here acid. This is what? Carboxylic acid. I am taking what? Conjugate base. Conjugate base. Now here C double bond O minus. C double bond O minus. NR3 plus. NR3 plus. NR3 plus. Second one is same set here like this. O minus. So what is this one? NO2. Next one O minus. Sorry, two carbons. Right. O minus. Next one is what? NR3 plus. Now guess what is the acidic nature, which means these are conjugate bases. So acidic nature is directly proportional to stability of conjugate base. Conjugate base is directly proportional to minus I. Directly proportional to what here? Minus I. Now, first let's see this one. First let's see this one. So what is the distance here? What is the distance? 1, 2, 1, 2. Same distance is there. Now here, what is the factor? Effect. NO2, NR3. NO2, NR3. NR3 will be more minus I. More minus I, more stability. So this is the acidic nature. Is it clear? Check it. That will be the acidic nature. NO2, NR3. NR3 is having stronger minus I than NO2. But in the first one, what happens here? Is it same or opposite? Is it same or opposite? Is it same or opposite? Guess it. Same or opposite? What is the reason? What is the reason? Same or opposite? What is the reason? Same or opposite? What is the reason? So your first set is having opposite direction. First one is having opposite. Acidic nature is not NR3 is greater. Not NR3 is greater than this one. Why? What is the reason? Reason is this. Let's see here now. Your first carbon. So this carbon is connected with two hydrogens. Here also it is connected with two hydrogens. sp3 atom. This is the bulkier COO minus. This is okay NO2. And here COO minus is bulkier. Now here NR3 also bulkier. NR3 also bulkier. Now here what will happen? Spherical repulsions. Spherical repulsions. What is it? Spherical repulsions. Here single carbon is having two bulkier atoms. So it is sterically inactive. It is sterically what here? Unstable. Spherical repulsions are there. That's why this molecule, that conjugate base is unstable compared to this one because of spherical repulsions. If it is destabilized, lower stability, then acidic nature what happen here? Acidic nature what happens, beta? Acidic nature will be lesser. That's why. So what is the acidic nature order? So this will be the acidic nature order. This will be the acidic nature order. This will be the acidic nature order. Is it clear? Is it clear? Check it. What is the factor here? What is the factor here? Spherical. Spherical is a factor here. Spherical stability. Spherical stability is less. Spherical stability is less. But if you take one more carbon, no problem. Which means here what here? C double bond O minus. So here one carbon, here one carbon. Next one is what here? NO2 and C double bond O minus. Next one here one carbon, here one carbon. Next one is what here? NR3 plus. So in the same way here carbon is what? O minus. NO2 from alcohol. Next one is what here? O minus. NR3 plus. NR3 plus. Now check the order here. First one is the first carbon, second carbon, third carbon. First carbon, second carbon, third carbon. So here distance is same factor. Distance will be same here. NR3 plus, NO2 plus. NR3 is stronger minus I, more acidic in nature. In the same way here also. So this is the bulkier. This is the bulkier. Okay. Now first carbon, second carbon. First carbon, second carbon. Okay. Distance will be same. Now what is the factor here? NR3 plus, NO2 plus. Sorry, NO2. NR3 plus NO2. NR3 is having what? Stronger minus I. Stronger minus I. And there will be no repulsions. There will be no repulsions. Because here two carbons are there. Because what here? Two carbons. So here it is what? Expanded. No problem. It is also what? Expanded. There will be no repulsions in between these two. So that's why here no spherical repulsions. Only factor is what here? Minus I. According to minus I, which is more acidic in nature? Which is more acidic in nature? So NR3 is more acidic in nature. NR3 plus is having what? More acidic in nature. So this is the difference. This will be the difference here. Spherical stability, careful. So here spherical stability would be working. Okay. Check it better. Okay, acids. Next one is what here? Acids. Single carbon carboxylic is formic acid. 2 carbon carboxylic acid is acetic acid. 3 carbon carboxylic acid is a propanoic acid. Propanoic acid. 4 carbon carboxylic acid is what here? Butanoic acid. Simple thing here. Simple thing. What is the rule here? First one is the hydrogen. Hydrogen rule is what? It is nearly neutral. It is nearly neutral, right? So acetic acid 1 plus I mean 1 methyl. Next one 2 methyl, 3 methyl. More plus I, less acidic in nature. So that's why formic acid is greater than acetic acid. Acetic acid will be greater than propanoic acid. Propanoic acid will be greater than butanoic acid. It will be greater than butanoic acid. It will be greater than butanoic acid. So this is the acidic range of normal carboxylic acid. Normal carboxylic acid. And one more point here, in between formic acid and benzyl carboxylic acid, which is more acidic in nature? Which is more acidic in nature? Which is more acidic in nature? So what may think here? What we have to think here actually? Minus I. Actually, hydrogen is having neutral inductive effect. That is okay. That is okay. Now, what is the role of this one actually? Sp2, right? Sp2 is nothing but what here? Minus I effect. Due to minus I, this benzyl carboxylic acid is more acidic than formic acid. That is wrong, because here distance dependent. So here polarity, this is what here, minus I effect, okay, minus I effect, okay, minus I effect, okay. Here we have to this much polarity is there, distance is the factor. It is too much what here, far away. This is not directly connected, too much far away. So that's why of course minus I is weaker minus I. Actually among, if you check it the previous video, what is the minus I order? Last one, nearly last, it is having what? Minus I, which means it is weaker minus I. First one is what? Strength of the phenyl minus I effect is weak. Second factor is distance. Now that's why here actually methyl is directly connected. Methyl is having actually plus I effect. So methyl plus I dominant over phenyl minus I. Methyl plus I dominant over phenyl minus I. So due to plus I, acidic nature is decreased. That's why formic acid is greater than benzyl carboxylic acid. So one more set is there here, that weaker minus I effect sets. Weaker minus I. Carbon COO minus. Here if you take here OH, if you take here what is that, any NH2, and last one is what here, I. Now compare with formic acid. Here first one is of course hydrogen is having neutral, plus I or minus I, nothing, only neutral effect, right? Now here distance is the factor. This is having minus I, okay, but weaker minus I. The two it is connected means it is near, not near, far away. It is what, far away here. So here this is the polarity. This will be the polarity like this. It is far away as well as weaker. That's why here methyl plus I is dominant. So this is very important. Methyl plus I is dominant. Now what is the role of this one? So it is what? More acidic than this one. In the same way, it is also having minus I, but weaker minus I and far away. So formic acid is greater than this one. The last one is opposite, because here En rule we have what? Alone element electronegative is greater than group electronegative. So I minus I and OH is there, which is more minus I effect. I is having what? More minus I, which means actually practically I is a stronger minus I component. Of course, distance is same. Distance compared to these two factors same, but due to having stronger minus I effect, it may polarize oxygen sigma bond also. It has that much of strength, so it is stabilized. It is stabilized because of stronger minus I compared to these two factors. That's why it will be more acidic in nature. It will be more acidic in nature. So this is the trend. Check it. This is the trend here. Stronger minus I effect. Like that, if you think here, stronger minus I, you may take here NO2, carbon, carbon, COH. Next one here, what? Formic acid. Next one is what here? NR3 plus C and COH. Of course, here distance okay, but here these two are stronger minus I effects. Now it can polarize. Not may, it can polarize the O sigma bond towards it. That much of strength it is. Having. That's why this is a trend. This will be the trend. Circuit beta. Clear? Is it clear? Concept. Plus I minus I applications. Plus I and minus I applications. One more application is the basic nature of amines. By using plus I and minus I. That we will see in the next video. Right? So if you have any doubt, and ask me in the comment section. Right?